Today we're doing the fifth set of notes. We're going to be focusing on the first page, front and back. So the very top of the page says review, and it says which of the following relations are functions. So first question we need to address is what is a function. So to determine if a relation is a function, no x values can repeat. And you can jot this down on the side of your paper. So no x values can repeat. And if you're looking at a graph, the graph must pass the vertical line test. So I would like you to look at the picture. So there's A, B, C, and D, and determine which of the relations are functions and which are not. So simply write yes or no next to the ones that have no x values repeating and the graphs that pass the vertical line test. So if you need to pause the video, go ahead and pause the video, figure out which ones are functions. Moving on to example 1. So the inverse essentially just means the opposite, and what I mean by opposite is that x and y flip-flop. So notice the relation is already filled in for you and they want you to find the inverse. So the opposite of the first coordinate will become now 1, -1. And again, when I say opposite, I don't mean the signs change, I mean literally x and y change. So the original coordinate of 0, 2 becomes 2, 0. 1, 3 becomes 3, 1. And 1, 4 becomes 4, 1. So again, the inverse just changes your coordinates. So for letter B, it wants you to graph both of these points on the graph. So the original one, we have a -1, 1, a 0, 2, 1, 3, and a 1, 4. So here's the original function. And then my inverse function is 1, -1, 2, 0, 3, 1, and a 1, 4. And notice the question asked, how is the line y equals x related to the graph? So y equals x is a line that goes exactly through the origin. And I want you to notice that your pictures are symmetric on either side of this y equals x. So your picture should always kind of look symmetric to this effect. So on the next page, for example 2, I want you to go to the right-hand corner of the page and we're going to write down the general process for finding the inverse. So on the back of the first page, on the right-hand corner, there's some space. So step 1 is to switch x and y. Step 2 is to solve for y. And below that, we're going to put a star, and what I want you to write is the domain and range always flip-flop for the inverse. And what I mean by flip-flop is that my domain becomes the range and the range becomes the domain for the inverse function. So now going back to the actual problem, for example 2, letter A says find the inverse. So following that two-step process, the first step is to switch x and y. So you keep the format the same, you just literally switch x and y. So x equals y squared plus 3. So that was step 1, switching x and y. Step 2 is to solve for y. So to solve for y, I subtract my 3 over. So now I have x minus 3 equals y squared. And to get y by itself, we take the square root of both sides. So y equals plus or minus the square root of x minus 3. And that is my inverse function. The reason we put the plus or minus is we brought the square root into the problem. So this is the inverse, or the opposite, of my original function. So now example B, we want you to graph the original and its inverse. So my inverse function, I'm just going to jot that down in the corner, was y equals plus or minus the square root of x minus 3. So we're going to go ahead and fill in a t-chart. We're going to plug in values into the original function. So we're going to be plugging values into this equation there. So if I plug in a 0, 0 squared is 0, 0 plus 3 is 3. If I plug in a 1, 1 squared is 1, 1 plus 3 is 4. If I plug in a 2, 2 squared is 4, 4 plus 3 is 7. So I can plot these points. So I have 0, 3, 1, 4, and a 2, 7. Okay, and this is going to be a parabola, so we know that my other points are just going to be reflected around. So a 4 and a 7 will be reflected, so I'll have a negative 1, 4, and a negative 2, 7. So here's my original function. So now we're going to do the other function, which is the square root. And again, remember my t-charts, all my values flip-flop. So this first coordinate will become 7, negative 2, 4, negative 1, 3, 0, 4, 1, and a 7, 2. So to plot it, we go to 3, 0, and then I have a 4, 1, but I also have a 4, negative 1. And then I have a 7, 2. So 4, 5, 6, 7. I have a 7, 2. And a 7, negative 2. So here is my inverse function. And again, notice that it's reflexive over this y equals x line. It's symmetric on either side. So the red one is your original. The blue one is the inverse. So letter C says, does your original equation define a function, and what is its domain and range? So the original equation is a function because it passes the vertical line test. And the domain is all real numbers, or you could say negative infinity less than x less than infinity. And my range is y is greater than or equal to 3. So keep that in mind when we go to answer the next question. So letter D wants to know, is the inverse a function? And an inverse function is not a function because it fails the vertical line test. So I'll say fails the vertical line test. And to kind of go back real quick and show you what I mean, I'm going to go back 2 screens. If I drew a vertical line, notice it failed. It crosses 2 times, so it failed the vertical line test. So remember, my domain and my range flip-flop. So the range for the last function was y is greater than or equal to 0. Or sorry, y is greater than or equal to 3. So that means my domain now becomes x is greater than or equal to 3. And the domain for the last one was negative infinity less than x less than infinity. So that means my range now becomes negative infinity less than y less than infinity, or all real numbers. And notice that should match your picture. So that's all for today.